Hey everyone, I wanted to make this video just to give you sort of an introduction to the first problem on our problem set for our first week of remote learning. Now, we haven't dealt with a pool table problem before in class, but the concepts behind the problem are things that you do know. We actually covered most of these concepts in semester 1. They're just being presented to you in a different way. Okay, so I wanted to work through part of 53 and a little bit of 54, but I don't want to spoil the whole problem for you. I do want you to try it on your own. So I'm not going to actually work through the entire problem. Instead, I just want to give you little helpful hints and nudges in the right direction. So we have our pool table here. And as you can see, the pool table is 100 inches long by 50 inches wide. Okay. And we have our pool ball here. It gets hit and it banks off the right side, banks off the bottom side, and ends up making its way into our top left pocket. Okay. And so what I want you to understand is that there are a lot of geometric properties happening when you shoot a pool ball across a pool table. Okay. And one of the things that's super important, and I don't know if it's as clear when you're looking at this diagram, is that when you shoot this ball and we're banking it across these two sides, we end up creating a bunch of different triangles. So I want you to see when I have this ball here and it goes down this line and it hits here on the right side, I've actually have created a triangle like so. And then as the ball moves away from this right side and ends up hitting the bottom side, I've now created another triangle on the bottom side. And then last but not least, as it travels and it makes its way to the upper left pocket, I'm also creating one additional triangle. Now these triangles do have a lot of things in common. Okay, they have a lot of things in common. One of the things is that these are all right triangles. Okay, hopefully we can see that this angle here would be a right angle. This angle here would be a right angle, and this angle here would be a right angle. Okay. Now this problem is going to involve two key concepts that we learned in first semester. The first one is angle relationships. And the second one, which we spend a long time focusing on, that's our first one, is similar triangles. Okay, and if we can show that these triangles are similar, then we're going to be able to solve the first part of problem 54. Okay, now just a quick reminder, we had 3 different ways of showing that triangles were similar. The first was side, side, side. The second was side, angle, side. And the third was angle, angle similarity. And the last little hint that I want to give you is that way in the beginning of the year, we played with these mirrors, right? Here's my drawing of my mirror. And we looked at what happens when we have a mirror and we have light hitting the mirror. So we see the light comes in, it hits the mirror, and then it bounces away from the mirror. And we learned that there is something special about the angles that are formed when the light hits the mirror and bounces off. And one of the key properties of this is that these two angles are equal. Okay, and that same idea is going to be applied to our pool table. When I have this pool ball being hit, and it hits the right side, and it banks off and starts heading this way, think of this as our ray of light hitting our mirror, which means that this angle here is the same as this angle here. Okay? Those two angles are equal. The same thing is going to happen on these two angles. Now, this angle and this angle are not the same, but I do know that whatever this angle is, it's going to be the same as this angle there. So hopefully we can start to see that we end up with similar triangles. Similar triangles by angle similarity. Because looking at these two triangles here, they both share this right angle in common. That's one of the A's. And they share this angle in common, which is the other A. So these two triangles are similar. The same can be said about these two bottom triangles. Okay? They both share a right angle, and they both share these angles in the middle. Alright, so that's my hint for you. I'm not going to spoil the whole problem, but these are some of the ideas that I want you to realize, right? When you have a pool table and the ball is traveling across the pool table, we have angle relationships and similar triangles happening. Alright, I'll see you next time.